you don't need to talk about merchandise that much, but in the beginning a little bit, and then in the end you spend a lot more time on the merchandise. Okay.
Hello, everyone. Another episode with Ramana Anamraju, and it is my pleasure to introduce Ramana. He is the author of Science is Not a Subject, Science Must Be a Lifestyle in our ebook, and we have a bunch of 3-minute stories, and tonight he's going to talk about one of them, and the person is C.V. Raman, and Ramana has a master's in physics. He studied nuclear engineering and computer science, and he has had years and years of experience in the healthcare field. So he's taken these interesting people from history and put them into a 3-minute story, and he's going to tell a little bit about that tonight for us. So Ramana, go ahead.
Thank you, Jennifer. Yeah, good morning, India. Good afternoon in California. Good afternoon in England, and good evening in California, and bedtime in the East Coast. Thank you all for joining. Today episode is very interesting. The reason I wrote the book is how the people from the past, how they relevant they are. Still, we are trying to catch up. He is the best example of that. Actually, if you C.V. Raman, the one I'm going to talk about, is prime example of why we need to understand those people, the scientists, what they did, how relevant is the present day technologies and present day advances, in fact. So, without a further ado, I'm going to play a video, and then after that video, then I do a small presentation. So bear with me. So I'm going to do a presentation now on the video presentation. Give me 1 second. Okay, I'm going to present to this video. Is watch this video, then I will explain a little bit concepts further.
His name is Chandrasekhara Venkata Raman. He was born in Tiruchirappalli, state of Tamil Nadu, India. His name is long with numerous alphabets, but get used for it, because the next few decades belongs to this man. He is descending from heavens to destroy cancer. Just not cancer, he is omnipresent in every field: science, medicine, technology, engineering, and even theology. Welcome to the world of Raman gadgets. Raman probe. Point Raman probe to anyone and just click flash, just as you do on your phone. It gives instant result that person has a cancer or not. No elaborate testing, no other diagnostic testing required. Cancer detection in seconds. Raman pen. Raman pen, point and click at the finger and tell you the blood sugar levels instant. No more shedding of blood drops by millions of diabetic patients. Raman scanner. Just place your hand gently on the Pharmanex Raman scanner. It gives you the fruit and vegetable intake and in correlation with the antioxidant activity in your body. By monitoring antioxidant levels may help you to prevent some diseases. Raman inspector. Raman inspector, a handheld instrument, is an invaluable tool for law enforcement. Just point and click, it identifies the counterfeit drugs. Just point and click and can tell you it is a cocaine or any other illegal substance on the spot. No labs, no other testing required. Just point and click and can tell you right there if it is a hair gel or explosive material in the container without opening it. Raman reporter. Just point and click and instantly tell you if that is a true Picasso or not. No other verification required. This is done deal. It is just taught. Raman optical tweezers, Raman microscope, Raman true norc, Raman imaging, Raman hyper, Raman transition. The list goes on. His name is truly omnipresent. This is not a science fiction. This is an extraordinary brilliance of a strikingly tall and dark handsome man from 19th century India. Hello, my name is Ramana Anamaraju and I have a passion for physics, specializing in allied healthcare and above all concern for all well-being of humanity. Sir Chandrasekhara Venkata Raman, usually referred as C.V. Raman, was born in 1888 near Chennai, India and died in 1970. He discovered groundbreaking quantum phenomena in the field of optics while he was working as a professor of physics at University of Calcutta, India. He was knighted in 1929 by Queen of England and awarded Nobel Prize in 1930, first non-Caucasian ever to win in the field of science. His discovery is called Raman effect or Raman spectroscopy or Raman scattering, which are named after him. We only see objects, including people, when light falls on them and reflect back to our eye. But once in a while, the reflected light also gives stunning details about the molecular and atomic structure of the reflected matter, like a rotational and vibrational energies of the molecules or atoms. This unique reflection was discovered by C.V. Raman and it is referred as Raman scattering, along with few other names. With humans, Raman scattering gives exquisite details about the cell structure and its function like no other modality we ever seen before. Raman effect is the only way you can identify rotten apple from real ones without touching, smelling or cutting. This non-destructive method is unique to Raman discovery, so thus makes an invaluable tool in the field of medical diagnostics without exposure to any radiation. A perfect tool for law enforcement without opening containers to check for explosives. A perfect method to check the authenticity of the age-old art without using any chemicals. Raman scattering analyzes vibrational and rotational spectra of the target material by using a non-destructive method. Cancer. At present, one of the most advanced methods of detecting cancer is through positron emission tomography, referred as a PET scan. This highly expensive and complicated equipment occupies 10,000 square foot office building or placed on 18 wheelers. The average cost for this procedure is around $4,000. Imagine exam that combines into a single scan the diagnostic imaging power of 10 PET studies, each measuring an essential dimension of cancer's aggressiveness, metastatic potential, and susceptibility to the radio and chemotherapy at the cost less than $25. Raman spectrometer, handheld Raman spectrometer can deliver the punch with a style. By attaching gold nanoparticles to the cancer cells, Raman spectrometer hunts every one of the cancer cells, identifies them, and kills them with a nano-heated guided missiles. Well-respected magazine Diagnostic Imaging describes Raman spectroscopy, a quantum physics technique puts all preceding medical imaging modalities to shame. Raman, the cancer Avenger, descended from heavens to rescue mankind from this fatal disease. Raman puts cancer detection is at our fingertips, figuratively and literally. C.V. Raman may be Hindu, but his discovery recanted the rituals in the church that happened centuries ago during early Christianity with the stunning details. Santorio delle Peregrina, 13th century historical church sitting near beautiful Cantabrian mountains in Spain. The church completely lost its original Romanesque Mudajar brick architecture through centuries of rituals and tourism. It is impossible to recreate the original architecture with all its colors and beauty since there was no historical data available. Raman spectroscopy came as a surprise savior for the church. Raman spectroscopy took layer by layer the centuries of environmental destruction, the dust left by oil lamps in 13th century rituals, natural decay of the bricks. Raman's Raman spectroscopy brought back the original image of the architecture with the stunning details. In recent years, 13th century Pilgrim Church was remodeled to its original architecture with all its beauty and grandeur. Thanks to Sir Chandrasekhara Venkataraman, a true scientist and a true patriot of India. In the field of medicine, Raman spectroscopy coming with a true revolution. You can literally test for cancer with the hand-held instruments at primary care offices or even at a boutique drugstores in coming years. By catching the disease at an early stage, dramatically reduces the cost of this fatal disease. A man from heaven gave a remarkable gift to humans. I am proud to share part of his name. Thank you for listening.
Hello, yes, hi guys. That I'm going to I'm going to talk about a little bit about Raman in more a little bit details. Some more new things happened. That's I did almost 5 years ago, 6 years ago. Is still valid, and then still so much going on in the Raman spectroscopy. I wanted to update you a little bit, little bit about that. Um, the I'm going to share the screen with you. That my again. So I'm going to put a slideshow from beginning. Yeah. So C.V. Raman, a Hindu that saved the church. I'll tell you what he did so much in the theology side, you will be surprised. But um, so you saw the video that was a little bit of
His
a.
name is
So now Raman spectroscopy they are using for COVID-19 rapid testing. POs, the point of care system because the PCR right now the antigen test is a home test, home kit is a lot of false negatives, false positive. The positives are okay, but the false negatives, the asymptomatic patients, they carry and they spread the disease. We don't have any quick way of judging those asymptomatic patients quickly. You have to go through a big test. So PCR test, as you know. So PCR test has a lot of things. You have to transport the sample, and then you need reagents for that. Supply chain is a bigger problem. Asymptomatic patients, he still has a problem with the PCR test sometimes. So so they are developing a new test for COVID. Is a Raman spectroscopy with the saliva. You don't need a nasal swabs and all these things. You can use the saliva, just spit it out, and then shoot right there, and it tell you whether there is 100% positive results for the whether somebody has a COVID or not. Is a uh, uh, phenomenally good in that it's fast and quick without all those going through immediately at the point of care system. It will tell you somebody has a COVID or not, even they are asymptomatic. So just you go to a drugstore and then shoot it, then that's it. That's the only way you can find out. So now in India, for example, India, China, and third world countries is a big problem. For example, this metmorphin they found out in a lot of in Delhi and in other parts of India and other parts of China and other countries, Indonesia. They found a lot of fake metmorphin, diabetic drug, as you know, very widely used by diabetic patients, type 2 diabetes patients. So that is a lot of fake medicines they're selling on the streets, and nobody knows that's people how many people got killed because of that or died because due to the fake medicines. It is a serious problem in some of the third world and developing countries. So Raman spectroscopy, Raman probe can shoot it right there on the spot, a sample, and can tell you whether what composition it has. It analyzes the vibrational spectrum of the tablets. What are the fillers inside? what are the chemical compositions and structure by molecule by molecule. It will tell you what kind of composition it has. So you will catch those people. So it is a very first forensics. It does in the real drug or fake drugs. It will catch in a second. That is, you don't need to go any other testing. You don't need to send to the labs or anything. That is the power of Raman spectroscopy. Raman spectroscopy, the main fundamental use, the main big advantage of the Raman spectroscopy is basically all of them are portable, extremely portable. Drug discovery side, cancer diagnostics, nanomedicine, clinical biology, forensics, all of them are, you could use the Raman spectroscopy with a handheld Raman spectroscopy. If you have an internet, that will connect with the library of molecular vibrational spectrum and compare that and tell you what's going on with each one of them. So it is really revolutionizing the healthcare. What is the Raman spectroscopy? I'm going to a little bit explain. So you see in the morning time, you see in the sunset, you see a beautiful colors in the sunset on the left side. You see that picture is a sunset. You see beautiful reddish orange colors, and everybody enjoys the sunset. This actually, and the right side is the blue sky. They say both are phenomena of scattering light. The light goes through the atmosphere, all the gases, oxygen, nitrogen they have. What it does is it scatters. Some of them are reflect, some of them are absorbed, some of them are partially scattered. This is the phenomena. Is a Lord Rayleigh invented that thing. That so he discovered that scattering. Lord Rayleigh from England is a physicist also. So the things that you see in the morning time and in the blue skies are all phenomena of scattering light. So that's a basic understanding of the lighting. So what he extended was, he also said that why the oceans are look blue. He said that is not the Lord Rayleigh analogy was that that basically that is a reflection of the sky. That's why the ocean is blue color. But in fact, Raman, he was coming from England in 1929 or 1927, I think. He's coming from England by ship, and then he saw that he could not convince, because it can be not the reflection of the sky. It has to be something else. Then he came back and did research, and then he invented the found out some of the light goes through these molecules and reflects, because it interacts with the water molecules and reflects that the blue color. It comes out. That is from the Raman. That is a scattering. He discovered that scattering. That is called a Raman scattering. So it's not the sky reflection. What he found out is some kind of a sky the scattering of the sunlight from the water molecules causes the blue skies. So basically, a light comes. Albert Einstein defined the light could be both wave and a particle. In this sense, it is a validation of the quantum phenomenon. The scattering, Raman scattering is in this context is comes as a photon as a particle. Photon travels, as you know. It is very interesting. It's basically from one place to the other place it goes. It's not a jumping. It is not going through anything. It is appears and disappears and appears someplace and the next place. So it is kind of a strange phenomena. But quantum phenomena is a quantum jump. That is not like going through a space traveling. Okay, so it travels, but it's a very mysterious way light travels in that sense. It's just appears, disappears, appears, disappears. That's what it does. That photon does. So when it falls on the molecules, like a atom or molecules or cells, it reflects. Most of the time, it comes out the scattering effect. It reflects it back. That's why I could able to see you and other people, because of complete reflection. So sometimes what it does is one in a million photons, which is the light ray, the light coming from sun, or what it does is it either absorbs, and sometimes what it does, it gives the energy to the molecule itself inside the atom itself. So atom vibrates a little bit more. All the electrons around that vibrations goes up because it gives the energy to the molecule or energy to the atom itself. So on the other side, sometimes it picks up the energy from the molecule, from the atom or the molecule, and comes out. So it is either sometimes it gains, sometimes it loses. When the outside, or the outcome of the particle coming out of the sample is always either more energy or less energy with a Raman scattering. Very small. That was a big challenge for Raman scattering. Raman scattering was in the beginning they got a big, they were very fascinated by that. There is a Robert Hood from John Hopkins. He was ecstatic about the Raman scattering, and he gave a ringing endorsement to Raman. So that's why he won the Nobel Prize in 1930. He was awarded a Nobel Prize for this thing. It is unlimited, unlimited. I can tell you, it can go, it can change, revolutionize the entire medicine. I'm not saying that because I have the same name as him. We are, Raman is, Ramana is actually, there is a Lord Venkateshwara in Tirupati in India. His middle name is Venkataramana. So we all, a lot of South Indians have this name Raman. So Ramana, Raman, these are all, I don't know where it came from, Ramanov, from Russia, all kinds of things. But anyway, that is the Nobel, he won the Nobel Prize for this. This Raman scattering is a very small scattering, but when the lasers were invented, then when you get the intensified lasers, then so what they did was they found out another way of getting a better signal from the Raman spectroscopy, because this is called surface enhanced Raman spectroscopy. You put a gold plate on the bottom of it, and then put the sample on the top of it, and then put the lights on laser on it. It comes out excellent signals from the sample. It excites all the atoms. Excitement means it either breaks the bonds or excite the bonds. Those kind of things is a chemistry basically. So when the cellular is vivo, the live imaging of the cells, basically what you can do is when you put a laser on it, it vibrates it and tell you the amount of the vibration and everything. It can tell you what kind of disease they have. It gives you such a exquisite details at the wall level, at the membrane level. It is a fun. It's a phenomenal details. It gives. There is no other spectroscopy can give you that kind of details. With the Raman, you can achieve surface enhanced Raman spectroscopy is a game changer in the microscope world, and the vivo imaging, which is a live cell imaging techniques, diagnostic imaging. So, for example, in the McGill University, they found out MRI. So one of the things is this brain tumors are very hard to do the surgery on it, neurosurgeons, because the cells, if they, you can't keep on opening the brain, because it's what happens is, so that they don't know where these cells are, cancer cells are. So what they do is they use MRI. You have to take to the patient again to the MRI lab and see where exactly these problems are. These details are not that good. Still, it is possible that cancer cells can evade this process. But Raman spectroscopy, with a Raman pen, just like a pen, small probe, it can hunt every one of the cells and see. It eliminates the views of fluorescence. It eliminates all the cancer cells. You can incision excise that materials from the brain, the cancer cells you can excite. So that is the power of the Raman spectroscopy is just a game changer in every way in the medical field. I'm just talking about medical field. It has the application of the material sciences, the aeroplanes manufacturing, in the lot of manufacturing, because you don't have to open it up and see whether there is alloy. So they're perfectly what they say is the strength of material. They want to find out the composition of the materials. So there is numerous applications in everywhere in the Raman spectroscopy. In coming years, you will see fascinated by Raman spectroscopy. Raman is going to be everywhere. That is already, you don't even know, but there are a lot of law enforcement uses all the ship containers right now. So a lot of people are using it. You don't know it, but the Raman spectroscopy is behind a lot of inventions. So Henry Brem is a neuro-oncologist from John Hopkins, said that this is a game changer. This is a really a powerful tool for a neurosurgeons, neuro-oncologists to remove the cancers. That's what John Hopkins, Dr. Henry Brem was highly appreciative of this invention. It's because of just so now I'm moving to gossip. He has a tremendous applications. We're all waiting for one more thing. Is that Jesus is married or not? I remember I told you that he was most of the a lot of churches were they what do you call it, remodeled because of his spectroscopy. They used his spectroscopy, but got all the colors, what they original colors and everything, because the Roman spectroscopy was using it, and they rebuilt the churches from a 10th century, 11th century. So very old churches, they remodeled and they rebuilt it from the same way exactly what was there during the time. That's one of them is in the Spain, the Cantabrian Mountains. So, so this is a big debate about it. Gospel of Jesus' wife. This is a this is in this context. In this, I am not a Christian. I don't know much about the Bible. My ex-wife is going to kill me about this, but I don't know. So it is kind of a controversial, I think. Uh, but anyway, it is in this particular thing. It says that Jesus said that Jesus made a mention of his wife. That's what they say. But there's a guy from Germany who has this, you know, papyri. I think I'm saying right. Papyri is a plant material. They write all these scripture was originally written in the scriptures were written. The problem is that so how do you know? The German guy said that I got the manuscript from he lives in Florida. He claimed that he got this manuscript that Jesus he mentioned about Jesus' wife in the during the first century itself, the beginning of John or somebody has written these kind of things. That's what he said. So that is validated. It has to be validated. So Colombia used ink techniques. They used a Raman spectroscopy to find out the ink, the composition of the ink during that time, during the period, and compared the ink structure, molecular structure of the inks to the Raman spectroscopy, and find out basically the result was possible. you know that Jesus probably married during in this time. So all the Christians don't need to come after me because this is just a research thing I'm suggesting. And the biblical scholars they did not dispute the Raman spectroscopy results. What they did was yes, possible, but the meaning of it is different, and they disputed the meaning. I don't want to be in that controversy. I don't know much about it, the Christianity itself. But I can tell you, so Raman spectroscopy is just a monumental in medical field. It is going to change, game changer. It is the diagnostics we need. 80% of our resources we spend on diagnostics. If there is MRI, CT scans, and all those things, if in the future, if you use Raman spectroscopy handheld instruments to diagnose on the point of care systems, you can send a medical assistant to the patient's home whether they have a cancer or not. You could do say that you don't need a lot of operator training. In fact, that's a great thing about the Raman spectroscopy. So Raman is a truly omnipresent. It is from the heavens. That. So he said that his quote is one of the powerful quote. Ask the right questions, and nature will open the doors to your secrets. A lot of times, we as a physicists always say that maybe we are asking the wrong questions. The medicine has to learn that. Medicine has to understand. Maybe we are asking the wrong questions. Maybe we need to come up with the right questions. The solutions may be better. Healthcare is a paradoxical system. The reason is that we think we need to solve the paradoxical system by asking the right questions. I think C.V. Raman gave a better hint, and then his discovery is omnipresent, omniscient, and I think people like him from the past, 1929, today, still we are catching up his results. Think about that. Still we are one fourth of the way of Raman's spectra to use it with full utilization. When it comes to the full effect, there is the world of 8 billion people. You get the access to care, unbelievable. You can solve one of the biggest problem of healthcare access and the delivery systems. Thank you for watching. And also, upon a personal note, just 1 minute, and I will get back and I'll bring Jennifer in a second. Um, um, One more thing. Thank you all. Lots of people compliment, send me wishes for my daughter's engagement, and hundreds of them. And I'm not I'm not the. Her looks came from, her looks came from my mother. Yeah. So anyway, thank you all for that. And I wanted to bring Jennifer. Jennifer is a confidant, the right hand, and she does it. She's a phenomenal woman. I think I cannot do without anything without her. I think she knows what is the essence of this whole process. Thank you, and let me bring Jennifer back to you. Yeah, you're on.
Thank you, Ramana. That was absolutely fabulous for sharing CV Raman with us. And in the ebook, there is a 3-minute story. And so it's really nice that you elaborate on telling us about CV Raman and all of his incredible accomplishments and what we're using in common day modern life just because of that. So it's also incredibly interesting. And, one of the goals of the ebook, Science is Not a Subject, Science Must Be a Lifestyle, is to take other concepts and put things that, involve science and math and create some curiosity. So the 3-minute reads that we have in our ebook kind of coexist with that. And with our lifestyle design here, this is just one example. So one of these designs matches each story and each historical figure in our ebook. It's kind of exciting because you can use these designs for anything. They can be any kind of swag that you want. You can use our logo. This is our Daily Wear for Medicine logo. And they're great for gifts for doctors and for people in the medical field, pharmaceutical companies, trade shows, anything like that you want to put some sort of swag design on that's different, that really brings curiosity and makes you think, brings on the thought, hopefully inspiring some innovations in and Ramana does that very well, and his stories are really, really good. So I want to thank you again, Ramana, for talking tonight about CV Raman. Truly appreciate it. And feel free to go and visit our website at www.dailywearformedicine.com. We would love to have you go in there and check it out and see what you think. And again, we will see you tomorrow. So thank you.